I am going to ask a question before I share my screen. This is the big question. And the question is, what is the relative size of planet Earth to the moon? So before I show you a picture, I want to be really clear on what I mean. And can everybody please unmute themselves? Unless, of course, you have special noise in the background that you can't get rid of. So, what I mean when I say relative size, I'm talking about volume. By the way, somebody's like crunching paper, or maybe actually it sounds like somebody's eating out of a bag of chips. If you need to eat out of a bag of chips, here's my best practice. Pour the chips into a bowl, and then you can just take individual chips out without making that bag noise, okay? There you go. Now, volume. I'm talking about the size, the mass, the volume of the moon versus Earth. What is the ratio? Who thinks they have an idea? Please raise your hand electronically to give me your ideas. And I don't see anybody raising their hand. Guys, come on. Is the Earth twice as big as the moon? Is it 3 times? Ben, raise your hand electronically. I know you can do that. Make it easier for me, and that way I always know when you've raised your hand. I'm going to start with you, Omer. Oh, and by the way, guys, there's a big risk. When you hear Omer's guess, do not anchor your answer based on Omer's. He could be completely right or completely wrong. So I want you guys to think independently. Don't get anchored. Omer, you're up.
I think it's like 2 times or 3 times bigger. I think 2 times.
All right, 2 times or 3 times bigger. Ben, what do you think?
From the Earth to the moon?
Well, it's the Earth to the moon, yes.
Well, it's, to be precise, it's 238,000 miles, 238,445 miles.
That is the distance from the Earth to the moon, but that doesn't answer the question. So Ben, that is correct. And Hayden?
I think the moon is much smaller than the Earth.
It is definitely smaller than the Earth. The question is, how much smaller? I'm going to go with you, Jack. And then Drew, I'm going to go with you.
So I think the moon is actually pretty big. I think the moon is like 3 times smaller than the Earth.
3 times smaller. Okay, I want to focus on that, but don't get anchored on that answer. Drew?
I think it's like 20 times smaller.
Interesting. Kennedy, Jesse, and then Alex. Go. Go, Kennedy.
My hand's not.
Okay, and then because it was up before, Jesse, what do you have for me, buddy?
I think it's probably 4 times.
4 times. And finally, Alex.
2.5 times.
All right, so guess what, guys? I'm now going to share my screen with you, which does not have the answer in it. So some of you said, and Jack, I was really interested in what you said because you said 3. Notice how the diameter of the moon, which is approximately 2,700 miles across, and look at it, guys, 1, 2, 3.5. Technically, it's 3.66, but I didn't ask you for the ratio of the diameters. I asked you for the ratio of the volumes. So work with me. What I want you to do right now is take your Play-Doh, please. Take your Play-Doh or whatever material you have, and I want you to break it up, and I want you to put it in I want you to make it into a nice workable cylinder. I do not care how much you start with. Push down the edges so you have uniformity.
The only thing I could find was a ton of rolled up marshmallows, so this is kind
You
of
know
hard.
what? Marshmallows are great. Jack, I just want to give you a little bit of caution. Jack, you are going to be dealing with big time stickiness. Okay, marshmallows get sticky like you wouldn't believe. But I happen to be an expert s'mores maker, and I'll teach you guys my mathematical method someday. Okay, you guys ready? Here we go. So first of all, what I'm going to do is I'm going to ask you guys to take your measuring tool. I do prefer centimeter ruler. And please measure. Mine is exactly 10. So what I'm going to do with my knife, which I have to find now, what I'm going to do with my knife is I'm going to create 10 equal sections. And I'm not going to worry too much about it. I'm just going to go every centimeter with my eye. And if anybody sees that I have now 10 equal sections, does anybody have a question about how to cut theirs up? You can give me your width and I can help you with that.
I think mine is 5.5.
5.5, so every 5.5 millimeters, Hayden, you're gonna have to make a mark. Alex?
Mine is 8.
So because 8 centimeters is 80 millimeters, everybody. Alex, you're gonna have to make a mark every 8 millimeters.
That's what I'm doing.
Beautiful job.
Except for the fact that I have paper, so I'm just cutting the paper into.
Absolutely. Paper is actually fine. By the way, Jack, no eating the earth or the moon. No eating the earth or the moon.
Also, I can't.
Are you guys ready? Everybody cut off 1/10, please. Everybody cut off 1/10. And I want to show you what I'm going to write on the page. I'm going to write 1/10. And then I'm going to put my 9/10 aside. Everybody take their 1/10 and make it into a nice cylinder, please. Make it into a nice cylinder. Now, you know what I just decided to do? I just decided to make mine into a rectangular prism. I'm kind of going to mash it down more flat, a rounded cylinder, and I'm going to try to make the sides look very rectangular. You guys see that? And give yourself a measurement, please. All right, everyone, mine is 70 millimeters. Write down your number of millimeters. Now, I want to show you something really, really cool.
Wait, I have a question.
Yes.
Like how many millimeters are in a centimeter?
Now, that is the best question I've heard. 1 centimeter equals, everybody say it, if you know it.
10 millimeters.
So all you have to do is take your 7 centimeters and tack on a 0 at the end. Now watch this, guys. I want everybody to write down their millimeter number and then put a fraction line, and I want you to divide it by 5. Now, I want to show you Mr. Kramer's special algorithm for dividing by 5. Are you ready?
Yeah.
Circle the number of tens, and all you have to do is double it. So what, in my case, what is 7 doubled?
14.
14.
14.
Go ahead and double your tens, and that is 70 divided by 5. And now I'm gonna mark off every 14 millimeters. 14, 28, 42, 56, and voila, I have just separated it into 5 pretty equal pieces. Now, once you have it separated into fifths, I want you to cut off 1/5, please. Everybody, please cut off 1/5. Now, I want you to take the 4/5 and put it on top of the other piece. Now, this is 1/5 of 1/10. Who knows what to do with 1/5 and 1/10? If I am taking 1/5 of, who knows what the English word of means when you translate it into men? Glad if you know. Please raise your hand electronically if you can. And Pete, I hope you're using paper or anything else or tofu. So, who thinks they know? Come on, take a guess. 1/5 of 1/10. It's either gonna be, guys, it's either gonna be addition, subtraction, multiplication, or division.
Oh,
Alex,
I think that's it.
I'm kind of just taking a guess, but I think it might be division.
louder, please.
Division.
And that was a great guess, because guess what? It's the opposite of division. Everybody put down a little dot in between the 1/5 and the 1/10. And everybody please multiply across numerators. 1 times 1 is what, everybody? Go.
2.
Uh-oh.
Wait,
1
no,
plus
one.
1 is 2.
1.
1 times 1
1.
is 1. What is 5 times 10?
50.
And guess what, guys? Your moon, which, by the way, today something very special happened to me. I was speaking to my best friend, who's been my best friend for over 40 years. And do you know what he told me? He told me that there's no special name for our moon. Every other planet has all these moons with names like Triton and who knows some other moons.
Sharon?
Deimos.
There's dozens and dozens of names. Guess what our name is? Moon. It's like naming me. It's like naming me teacher. What's his name? His name is Teacher. Okay. So here we go, guys. This is your moon. Put it down next to the 1/50th, and then make an Earth, please. Take the 49/50ths and make that into the planet Earth. Now, guys, I always thought that there was some special relationship between the diameters and the volume, and there is. So I want you guys to do this for me. I want you to now, did you guys bring a calculator with you?
Yeah.
No, but I'll go get one.
On my
Yeah,
computer.
I asked your parents to have you with a calculator, and it's gonna be a little bit difficult to do. And if you don't have a calculator, please don't worry. And I want you guys to key in these numbers. Are you ready? Now I'm gonna erase this. So by the way, we now know that our Earth to Moon is approximately a 50-to-1 volume relationship. 50-to-1 volume. However, everybody look at this. The diameter of the planet Earth is about 8,000 miles. And I'm going to tell you the exact number. Key into your calculator 7,917.
Wait, how do you make that number?
7,917. That's the diameter of
7917.
Earth.
That's it.
Somebody has a question? If you have a question, you can ask it now. Okay, now, somebody's starting to annotate. I do not want that to happen. I'm going to disable that. So please clear your annotation. Clear.
Mr. Kramer, I have a question.
Yes.
Doesn't it depend on where the moon is? Because the moon moves sometimes.
Yes, but we're talking now about the volume,
Oh.
which is the size. Now, if you're talking about distance, Kendra, then the position of the moon makes a big difference. I want you guys to take that number and I want you to divide it by the diameter of the moon. And the diameter of the moon is approximately 2,160 miles. Go ahead and hit division and then equal.
Whoa.
And guess
Wait,
what?
not done yet. Wait.
That's
You guys get 3.66.
Yes, 3.66.
I got
7777778.
Do not read digits. Please do not read digits. But 3.6 or 3.66, pretty good. Now just erase the other 6. Erase the other 6. And Jack, you have a question. Go for it.
So I broke up after you said division. What was the next number?
Okay, hold on one second. Unfortunately, we have helicopters in Boston right now hovering, so there's noise. And that's why I left you for half a second.
You
So
live in
Jack,
Boston?
Jack, pay attention here. 7,917 divided by 2,160. You should have gotten 3.6. And that's how much bigger the diameter of the Earth is than the moon. Now, I want you to do this. 3.6 times itself, and then that answer times itself. Essentially, what we're doing is we're cubing the linear ratio, the diameter ratio. We're creating a cubic or volume relationship, and do not say it out loud. Do not say the answer out loud, please. And I can just hit to the third power on my calculator. If you know how to do powers, you can do 3.6 to the third power. And what did you guys get? Anything familiar up here?
I got pretty close to 50.
Did
Yeah,
you
I
guys
got
get close to 50?
46.5. No,
What?
56.
I got 46.656.
Yeah.
Right.
I got 46.656.
That's what I
Yeah,
got.
me too.
If you got 46, that means you probably did not key in. Well, actually, no, that would probably work for me. 4.6 to the third power. Yeah, I think 46.65 is pretty good. So guys,
It said
this is the relationship.
26.8.
Now watch this, guys. Everybody look at the picture you're looking at now. This is the actual relative size, 3.6 diameters, and now we know that the volume ratio, is 50-1. Now, everybody pick up their Earth and their moon. Now, I don't think you're seeing this now. I'm gonna have to try again. New share. Uh-oh. Oh, no. That's what the problem is. The problem is I'm annotating. Okay, here we go. I want you to hold out your Earth.
Wait,
and
I
then
can only
hold
see
out
the.
your moon, and I want you to spread them as far as you can with your arms. And guess what? That is not even close to represent the relative distances of the moon and Earth. In fact, what you're going to have to do is you're going to have to get up and you're going to have to move your moon twice as far. I'm going to put mine down here, and I'm going to come back, and now Earth and my moon are 240 centimeters away. So here's what I'm going to do. I'm going to try this again. So we've got a 50-1 relationship, and the distance between the Earth and the moon is 240,000 miles. Now, Ben gave us earlier in the lesson, he gave us a more accurate number, but let's go with 240,000 miles. You guys see this? 240,000 miles. The question is, don't say it out loud, how many Earth diameters would we have to do? Remember, the distance from the Earth to the moon is 240,000 miles. The Earth's diameter is 8,000 miles. What would we do with 240,000 and 8? On 3, 1, 2, 3, go.
30.
Well, I didn't ask for the answer. I asked what would we do with 240 and 8,000?
Divide them by 2.
The answer is to divide them.
Yes.
And I want you guys to write that as a fraction. Whenever you write division, please write it as a fraction. And now we are going to do the division in a way that actually uses simplification. So the first thing I want you to do is I want you guys to divide the top and bottom by the same number. What number do you think you should divide the top and bottom by?
Maybe 2.
That would be good, but there's a bigger number that's easier. Jesse, you had your hand up? Okay, watch this, guys. 1, 2, 3. 1, 2, 3. What have I just divided the top and bottom of my fraction by?
3.
Answer?
3.
1,000. I mean, guys, 8,000 divided by 1,000 is 8. 240,000 divided by 1,000 is 240. So you now have a fraction that reads 240 divided by 8. And somebody said it earlier, but wait a minute. Couldn't we divide the top and bottom by 2?
Yeah.
Let's do it, guys. Go. Come on, 120 over what?
120.
Over. Let's do
4.
it again. Come on, divide by 2, divide by 2.
2 and 60.
2 and
Not 2 and 60. We read top down. 60 divided by 2. And do it one more time. Come on.
31.
30 whole, which of course is just 30. And what I did for you on page 3, guys, on page 3, I put 30 Earth diameters side by side. So 30 times 8,000 gives you 240,000 miles. Now, just to give you an understanding of what that means, I want you to look at this picture. Do you guys see this little green dot at the bottom?
Yes.
Yeah.
That green dot
Yeah.
represents the International Space Station, which is 254 miles above the surface. Doesn't it look like it's right against the planet Earth?
Yeah.
Well, guess what? Relative to the moon, it is. Look at this green dot. That green dot is 12,000 miles. If you remember when we did the lesson on GPS satellites, that's how high the GPS satellite is. And now, guys, if you count by 8s, you will literally see the moon at 240,000 miles.
Oh my
And
God.
do you know what I say when I say 240,000?
What?
I say
Kilometers.
250,000. Because isn't 250,000 exactly a quarter of a million?
Yeah.
Yeah.
So guys, when you think about the Earth and the moon, when you look up in the sky, I want you to next say, guys, that's a quarter of a million miles away. Now, let me ask you this question. Why, how much bigger than the moon is the sun? Remember, we're talking here about volume. We're not talking about diameter. You know that the volume ratio from the sun to the earth is 1.3 million, 1,300,000 to 1. The earth to the moon is 50 to 1. So who knows what we'll have to do? By the way, addition, subtraction, multiplication, or division. Which are we going to use dealing with these two numbers to come up with the sun to the moon?
Division.
Division.
Well, remember, the sun is, okay guys, I'm gonna draw it for you here. Ready?
Multiplication.
The sun is to the earth.
Yeah, multiplication.
So here's the earth, here's the moon, and here's the sun. The sun to the earth is 1.3 million. The earth to the moon is 50. So to go from the sun to the moon, we're gonna have to multiply. Everybody do the multiplication right now. And do not say your answer. You can send me a chat with your answer. You're multiplying 1.3 million by 50. And I strongly recommend that you do not include your zeros until the very end. So I'm looking for a chat. And a little hint for you guys. If you do 13 times 5 and tack on these number of zeros, you got your answer. Ooh, I like it. Claire, can you read your answer, please?
65 million.
Now, guys, do you agree that 13 times 5 is 65?
Yes.
How many zeros do we have here? How many zeros do we have here?
6.
6.
6 zeros, and therefore the volume ratio of the moon, of the sun to the moon, is 65 million to 1.
I put the wrong amount of zeros in it and I messed it all up.
Now, guys, I want to just show you what I'm going to be doing with the older kids next. Are you ready for this?
What?
We are actually going to take something called the cube root of 65 million.
What does that mean?
I know.
Hold on. What that means is, and by the way, we're going to change 65 to 64 to make our lives a little bit easier. If you find out what number times itself 3 times equals 64. So the cube root of 64 times the cube root of 1,000,000. And I don't expect you guys to know this just yet, but who knows what, like, look, if I do 2 times 2 times 2, I get 8. Therefore, the cube root of 8 is 2. If I do 3 times 3 times 3, I get 27. The cube root of 27 is 3. So what's the cube root of 64 on 3? 1, 2, 3, go.
8.
Not 8. The cube root of 512 is 8.
4.
And if you said 4, you are correct. Who knows what number times itself 3 times gives you 1,000,000? Just look at those zeros.
6.
6.
Divide the zeros by 3, guys. And therefore, 100.
33,300,000.
And so guess what? Since 100 times 100 times 100 is 1,000,000, 4 times 4 times 4 is 64. Smush them together. And the diameter ratio of the sun to the moon is 400 to 1. So can I ask you guys a question? Is this picture a silly picture? How is it possible
Yes.
that the sun looks exactly the same size as the moon? Don't answer it out loud. Raise your hand electronically if you can tell me why the Earth and the sun look to be the same. Maddie, we'll start with you.
Because the sun is farther away in the picture.
Oh, that's a great answer. I'm looking for a little more detail, Jack.
Because of the distance between each one and the view that they put this at.
That is true. And Jack D, did you have something to add to that?
No.
Okay. Anybody else? Guys, we know that the sun is 400 times wider than the moon. But what would make it appear to be the same? And I'm gonna ask Maddie, because Maddie, you started to talk about it. Oh, Alex, go for it, Alex.
Well, maybe it's because if this picture was taken from closer to the moon, then it probably makes the moon look the same size since it was taken closer to the moon.
Well, by definition, since the moon is closer, we know that it was taken closer to the moon. But it was taken from the same point on the planet Earth. I have always marveled that the circle is exactly the same size. And here is why, guys. If you look at page 6, it shows you that the sun's diameter divided by the moon's diameter, and you can do this later on your own, but we just did the math and showed that it is 400 times. Now, Maddie said that the sun is further away. How much further away? The sun is 93 million miles from Earth, which is called 1 astronomical unit.
AKA.
And Alex, you had a question?
I was gonna give an answer
To which? To what?
to the question you just asked.
Okay, go for it.
Well, the moon I think is like 26,000 miles away, and if it was taken from the Earth, and if it was taken closer to the moon, then the sun would be about 67,000 miles away from the moon.
Yeah, I hear you, but the moon is way further from the Earth. It is 240,000 miles. Now, I want you guys to go to page 7 for me. Go to page 7. We are actually going to use a different number for the AU. And I did this on purpose because it's going to be easier for our calculation. We're going to use 96 million miles divided by the moon distance, which is 240,000. Now remember, guys, what's the first thing I do? I divide the top and bottom by what? Who's got that? Come on, who can raise your hand? Ava, I want to hear from you. Jack, Rafa, I want to see your videos if you're okay with that. And then I want you to unmute yourselves because that would allow you to participate. All right, Rafa, what do you think we're going to do? Divide the top and bottom by what?
Divided by 10,000.
And that is right, guys. You're actually dividing the top and bottom by 10,000. Everybody write down now 9,600 divided by 24. Now, guys, I would like you to start by dividing the top by 3 and the bottom by 3. Now, the way I do this, just so you know, when I write out 9,600 divided by 3, do you see how beautifully 3 goes into 9? How many times?
3,
And 3 goes into 6?
2,
And therefore, we have 3,200. And you know what 24 divided by 3 is. Go.
8.
All right, now cut them both in half. Cut them both in half, guys. 3,200,
1,500.
1,600. Cut them both in half.
2 and 3.
802.
800
And
and
cut them both in half.
400.
401.
And guess what, guys? The Earth and the moon and the sun's diameter is 400 times larger than the moon's diameter. And the sun is also 400 times farther from Earth than the moon. It is the most amazing coincidence. Now look at this. I drew you a picture. You are right here on the planet Earth. That's you. You are 250,000 miles from the moon. And you see the exact same width of your circle. So the circle that you see, guys, the circle that you see is identical for both. Now, that is why when we have a solar eclipse, you can't see the what?
Moon.
Moon.
You
Moon.
can't see the sun because it's blocking the sun completely. Now, I have good news and I have bad news. Are you ready for good news and bad news?
Yeah.
Here we go. And Maisie, put your paper down, honey, so you can see the screen. So the good news is that in 11 days from now, there is going to be a solar eclipse. That's the good news. I have bad news for you.
We
What's
can't
the
see it.
bad news?
You're going to have to travel to either Africa, Southern Europe, or Asia to see it. And even if, guys, listen to this, even if you decide to travel, the clouds could be out that day. So a lot of things have to happen. Now, just so you know, even though I know it's not going to be very visible from the United States, I'm going to have my binoculars ready to go on June 21st. It happens to be my dad's birthday. He's passed away, but I still celebrate it every June 21st.
It's
It
my
happens to be
dad's
the
birthday
first-
too.
It's the first day of summer.
Solar eclipse on the summer solstice.
Wait, I thought that was Father's Day.
Wait. Who just made that connection? That's a really cool connection.
And me.
Right, that's what-
Today's my dad's birthday.
Very nice, Jack. Somebody has another question, I think.
And
Father's Day.
Father's Day.
Oh, that's right. Now, are you guys ready for the next exploration? I want you guys right now to do this for me. Go to page 10, which has a picture of the solar system. And what I did was I put a big S on the left and I put a big P on the right.
Wait,
The
what
S
page are we
represents
going
the
to?
sun. Please raise your hand if you have a question. Don't just speak because I'll be speaking at the same time. Thank you. The sun is the S. The P is Pluto. Andrew? Andrew, you raised your hand. I'm calling on you. Go for it, buddy.
We actually have two more planets in our solar system than this map shows.
You know, and do you remember what they're called?
on the web.
Andrew, do you remember what they're called, buddy?
I don't remember what they're called, but I remember they're like somewhere under Uranus and somewhere under Neptune and Pluto.
Wow. You know, what's really interesting about that is I've been studying the moons quite a bit. And I want to tell you a little bit about that because it could very well be moons for other planets that we're seeing. But guys, I have a theory. Are you ready for my theory? Drop everything and listen. I did an analysis of the diameters, ratios of all the planets and their moons. Now you remember that our planet, Earth, is 3.6 times bigger than the moon diameter-wise. Now, I looked at all the other planets and their moons. The closest planet to that ratio is Neptune. Neptune is 8 times wider than Triton, its biggest moon. Even Jupiter and Saturn, who have huge moons, they are tiny in comparison with the planet. So here's my theory. The reason why we have life on Earth and not anywhere else is because our moon is so big. Because our moon is so big, it has its own gravitational force, which causes our tides to rise and fall. It creates the seasons. It affects everything on our planet. And in my opinion, that is what gave the sort of chemistry of life. Now, I have no idea I don't know if I'll ever be able to test it, but I certainly want you guys to think about at least that theory. Okay, what I want you to do right now is put in where you think Mercury is, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune.
I don't get it.
Well, I think Mercury is about there. I'm trying to figure out the distances, and I'm trying to fit them all in the picture. And that's what I think.
To send to you?
Say again.
What are we supposed to send to you in the chat?
Don't send me anything right now. All I want you to do is draw on your page 10, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, where you think they are relative to each other. Jack?
I'm actually on vacation right now, and I don't know how to work the printer here, so I didn't get the PDF.
Do me a favor. Can you write down an S and a P and then MVEMJSUN?
I can.
Do that right now. Do that right now. Now, guys, I want you now to watch what I'm going to do. I'm going to go back to the overhead screen. I'm going to go back to the overhead screen. And here's what I want you to do. Rip off the last page. Rip off the last page of your packet, which will be graph paper. Just rip it off.
Page 16?
Page 15 and 16. It doesn't matter. And I want you to fold it the long way. Now, what I want you to do is I want you to write, this is what I think. This is what I think in terms of the planets and where they're situated relative to each other. Put an S and the P, and then I want you to write in, whoops, that dried out, hold on. I want you to write in Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And I'm going to do the same thing that I did before, because that's what I think their distances are. And you should have something that looks like that. Now, we only have a few more minutes, so here's what I want to do. Turn the page over and right on the top, reality.
What?
Reality means the
Oh, they're in the circle.
real distances. So everybody do another S and P. Now, you know that 1 AU, the distance from Earth to the sun, is 93 million miles. Now, I don't know if you would believe this, guys, but Pluto is 40 AUs from the sun. It is 40 times further away than the sun. Now I want you to find the midpoint.
How do you find the midpoint?
Well, there are two ways to do it. You can either fold the paper, and wherever that crease is, that will be the midpoint. But I like to just do it by my eye. And I want you to write the planet Uranus, a U. Now, how many AUs is that, guys? Come on, if Pluto is 40 AUs away, then Uranus must be 20 AUs. If Uranus is 20 AUs, put a dot in between Pluto and Uranus. That's your Neptune. How many AUs?
30.
30.
30 AUs from the sun. Now, do the halfway point from Uranus to the sun. And that planet, everybody, has rings. That is Saturn. And that is 10
10 AU.
AUs, which, by the way, I love the number 10. So therefore, it must be 930 million miles from the sun, and that is close to 1 billion miles. Now, go from Saturn to the sun, halfway. That's your Jupiter.
What?
And Jupiter is 5 AUs.
How is that Jupiter?
Jupiter is about 500 million miles, 500 million miles away from the sun. Now you're not going to believe this. Go halfway again. That, my friends,
Wait,
is
how do you go
not-
halfway? I don't get it.
well,
Don't
halfway
snooze.
from Jupiter to the sun.
But how do you go
Halfway.
halfway if there's only 2 squares?
Oh, don't worry about the squares. The squares are there because the margins cut off squares on the end. Don't worry about that, Hayden. Everybody, guess what this is?
Mars?
Earth.
Earth. It's Earth.
It's the asteroid belt.
Oh.
So guys, it can't be Earth because Earth is 1 AU. This is 2.5 AUs away, which is the asteroid belt. Now go halfway.
Probably either Mars or Earth.
Or
Can't
the
be-
moon.
Can't be Mars, can't be Earth, because
Is it
half
the
of
moon?
2.5, who knows what half of 2.5 is? Say it on 3.
1.2,
1, 2, 3, go.
1.25.
And 1.25 AUs is Mars. 1.25 AUs is Mars. Halfway from Mars to the sun, guys,
0.63, I'm pretty sure.
is Venus. And that's about 0.6. And then guess what? Halfway between Venus and the sun is Mercury. And
That's
then
0.3.
my favorite planet of all time is between Venus and Mars, and that's where we live, and that's Earth, which is 1 AU away. And everybody now, open up your sheet, and you can see the difference.
I didn't get to finish the reality one.
Do not worry about that, because I gave you answers in your document, okay? And I also gave you a write-up so you can take anybody through this. I don't think anybody would know the actual relative distances. This is what I thought up until I did the research. Until I did the research, I thought the planets were equally matched. Now, what I'm gonna do now is I'm gonna go back to our screen here. And I want, do you guys see the big screen now?
Yeah.
Yeah.
Look at this, guys. Even if you see the actual size
It's
picture,
5:30.
the actual size picture looks exactly like every other picture in terms of distances. And you know that reality is this. So let's count down from Pluto. Are you ready? We're gonna say -40 AUs, Pluto. Go. Negative
-38.
38.
Is Neptune.
Negative 20 AU. Uranus.
Uranus.
Negative 10
-10
AU.
Is
Saturn.
Saturn.
Negative 5 AU. Jupiter. Negative 2.5. Asteroid belt.
belt.
Negative 1.5
1.25
Mars.
Mars.
Negative
Negative
0.75
0.5
Venus.
Wow.
Negative
Negative
0.3
0.3
Mercury. And then, of course, Earth is 1 AU away.
Negative
How far, by the way, how many AUs is the sun from the sun?
Zero.
0 AU.
Negative 0.
Oh my God. 2, 4, 6, 8. Oh, do we appreciate Matthew. Matthew. Go, Matthew. Guys, you are becoming astronomers and mathematicians overnight. Have a great week. I'll see you on the other planets. Okay? Just don't leave without me. Don't leave without me. Bye, Andrew. Bye, everybody.
Bye.
Don't leave without me.